Hi there, and welcome to the AbsInt videocast for the release 24.10. My name is Christian Humbert, and as usual, I'd like to present the latest features of our binary level analyzers, AIT, StackAnalyzer, TimeWeaver, ValueAnalyzer, and TimingProfiler. Well, the first new thing to tell you about is we have introduced a new icon theme. This new one is much more flat and modern. But besides from this cosmetic change, we of course have a number of new functional updates as well. Let's go through it. For those of you who prefer to use the keyboard instead of the mouse for navigating through the project or to switch to different views in the graphic user interface, we have good news because we introduced a so-called go-to-everywhere new head-up display. So for instance, if you're here in the disassembly view and you would like to get some more information about some variable in the symbols or dwarf view, you could now use the shortcut Control P to open the head-up display. There you can just simply start typing the view or the name of the view you would like to switch to. For instance, here symbols view. And by just hitting enter button, you end up in the symbols view. If you want to go back, for instance, to any of the analysis, for instance, you would like to switch to the initialization analysis, you can just simply type in the name, the analysis item of the item, and well, then you are there, and then you can start analyzing it. The next new feature is the new Analysis-dependency graph. You might have seen this new button in the analysis overview. It allows to toggle dependency graph. Well, if we activate that, we see the new dependency graph for analysis. And well, in this example, in this project, it looks quite boring because there is no dependency at all. But let's now work on that. So we go to our 1 millisecond task and introduce a dependency to some value analysis, for instance. So by clicking here on dependency, we select the initialization analysis here, and we make ourselves depending from the 1 millisecond task value analysis as well. So we have two dependencies, and if we go back to our analysis graph or dependency graph, we now see this visualized here as well. Also, if we introduce resulting elements or result combinations, for instance, by clicking here and saying, well, we would like to have a global stack usage for the following formula, we take the, let's say, 5 millisecond task stack and add the maximum of the, let's say, interrupts. Where is it? The one interrupt service one, routine 1 and the interrupt service routine 2, because they cannot interrupt each other. They have the same, they share the same priority, but they might interrupt the 5 millisecond task. Well, now going back to our dependency graph, this is nicely visualized as well. Here, you see, we introduce a global stack usage result, our result combination, which is now of course depending on our results from the interrupts, the two interrupts, but also the task result. So this can nicely be visualized here in the dependency graph. If you want to have a much more cleaner look here, you could, for instance, also say that you would like to hide those analyses which are independent. So we restrict the graph just to those analysis or result combinations which show some dependencies. You can also make the graph specific to one analysis. So for instance, if you want to focus to just this 1 millisecond task, you could say, show me just a dependency graph for my 1 millisecond task value analysis. And you see it is used just in our 1 millisecond task estimate analysis, which was depending on the value analysis. In this release, we have improved the experience with groups in the A-Cube project. In this example, we have defined 4 different groups here, one for the timing estimation analysis, and we have put 5 individual analyses here grouped together. Then we have 5 WCET analysis here grouped together, 5 stack and 2 value analysis. Well, now assume here you have forgot to specify report files, file names for the individual analysis of that group. You see, they are all blank here. You can now go to the group definition here and say right mouse click, edit analysis, and everything you change here in the configuration now affects only those analyses grouped together in the selected group, right? So we could, for instance, here introduce a report file name, which shall be the name of the analysis with some WCET suffix and a .txt extension. Well, and if I click on OK, then you see that all my analyses here have now a specified report file name. No? In addition to that, you can now also use the create analysis dialog, for instance, from the symbols view. Let's search for the 5 millisecond task as an example. Assume you would like to introduce a value analysis of that 5 millisecond task. You can say create analysis. And now the create analysis dialog allows you to select between existing groups. So you could say, okay, I'd like to add this new analysis to my set of value analysis, right? And then it will be added to the selected group. As you know, in AIT and TimingProfiler analysis, you can define so-called additional starts. For those additional starts, individual cache and pipeline and path analysis will be performed while still relying on the entire value analysis information. So in this example, I would like now to do an additional start analysis for all directly called functions out of proc 0, for func2, proc1, and so on. Well, for that, I need to specify a specification, routine, proc 0, descendants, additional starts, and level 0. With that specification, I tell the analyzer to consider those directly called functions out of proc 0 to be additional starts. And this looks like this. I perform here play, and then you see it performs the overall value analysis and individual analysis for the specified additional starts. In the overview, this looks like this. Now assume I would like to do the same for the 10 millisecond task estimation. You can see that the overview becomes quite large. In this release, we now introduce the foldable additional start view. So you can get rid of that view here of these additional starts and keeping the overview small again. Now, this is indicated by this small triangular here. In the new version, the statistics view has been improved as well. We have introduced a new filter in the object size information. So let's open here in this example the statistics view, selecting the object size. Well, let's expand everything recursively to see that here we have a lot of functions and variables linked to the various memory modules here, the level 2 SRAM, level 2 flashbank A. But this information here is not analysis specific to our 10 millisecond task yet. This is a global object information. Now you can use the filter contribution and say, I'd like to filter the output here to my specific analysis. And now just those functions and objects are remaining which are reachable and used in the currently selected analysis. The last but not least demo in today's release video is about TimeWeaver and a new coverage information that we compute and visualize. For that, let's switch to the statistics trace coverage view. Here you see it seems we have perfect coverage information, like 100% instruction and 100% trace edge coverage. However, there is new information computed called the trace flow coverage information. I just add that here to my statistics columns, and we immediately see that, well, in our entry function, we have just a reduced trace flow coverage. Let's inspect that in the graph in more detail. For that, I'd like to recursively expand my function and scroll down a bit. And we immediately see edges where the timing node of these edges are again surrounded by this orange color. This indicates that if we execute that block here via the selected incoming edge here, we have found in the trace files over every trace snippet we extracted, just always an outgoing execution over that left edge here. In other words, it was never the case that when we entered this block via the selected entry edge, that we left it over the right branch. Here we have another example. If we select the right edge, it's vice versa. In all the trace snippets we have seen and extracted from the trace data, we always enter this block here by this edge and left it by the right one and never by the left one. So this gives you an information on maybe how to improve your or add some more test situations, test executions to also trigger the other combinations in your trace flow. This concludes my video for the October release 24.10. As usual, you can find much more information about our changes on our release note website. Thank you for your interest again. Take care and bye-bye.